Hi, everyone. I'm Andy McAfee, and I want to welcome you to the final IDE seminar of the fall semester. We will be back in the spring, so stay tuned for that. We are ending on a fantastic note. We have with us today Rishab Mehrotra, who is a senior research scientist at Spotify, and he is going to address and hopefully answer a question that I have actually been wondering about for years, which is, how is it that Spotify knows my musical taste so much better than I know my musical taste? And then by extension, how do we get these multi-platform, multi-stakeholder platforms to get better at their recommendations and at their other activities? Rishab, over to you, please.
Perfect, great. Thanks, Andrew, for the introduction. And yeah, it's an honor to be here presenting to this great audience on this topic. And I know a bunch of you have decades worth of experience on this topic. So it would be great to have your comments, and I hope like we can spark off some collaboration for going forward. So I'm Rishabh. I'm a senior researcher with Spotify based out of London. So I'm streaming from my home in London right now. You can see like it's getting dark outside, 4 p.m. sunset. So this talk today, we're going to talk about like multi-objective recommendations on multi-stakeholder platforms. So essentially, what we're going to cover today is I'm going to briefly talk about the different recommendation problems we have at Spotify, and then dive deeper into the multi-stakeholder problems. So essentially, it's going to be roughly about like 45 to 50 minutes of content. I'll be monitoring the questions on the other screen, and I'll pick it up as we go along, and then like we can keep some questions towards the end as well. So I'm going to start with like just talking about traditional recommender systems and why it's been just user-centric and what can we do with it. And then I'm going to focus more on setting up a bandit-based model for the homepage construction of Spotify, and then like work from there to talk about multi-stakeholder problems. So yeah, I've been with Spotify for close to 3 years now. I did my PhD at UCL, and before my PhD, I was at Goldman Sachs, so coming in from like finance background to recommendations in music. What we do at Spotify, at least my team's mission. So I'm part of the personalization team. We are about 350 people in total across the world, my team specifically. And in general, like the goal for us is to connect listeners and creators in a unique and enriching way. So right there itself, we're starting to see that we value not just the users, but also like the creators. So it's a two-sided or a three-sided marketplace, which we kind of operate. So to do that, we're looking at recommendations at scale. An interesting part here is the number of tracks and the number of playlists, right? So we have over 60 million tracks, so that means there's no way users can kind of comb through all of that and find the content which they would love. So that's why recommendation is the key challenge here. So now what we do at Spotify is we kind of offer many different recommendation products. So essentially like a playlist can differ based on the listening patterns. So we create a lot of these playlists for you using editorial input or using some algorithms guiding the editorial inputs. We have radio sessions. So these are sequential decision-making criteria. So you can start a radio session and like we kind of continue that sequence for you, and hopefully you continue streaming and like enjoy the music we surface to you. We also have like search. So again, like typical problems in any search setting is kind of what we tackle. We do a lot of work on homepage. So homepage is the default page you use when you open the Spotify app on your homepage, on your mobile phone, or even on your desktop client as well. We have some genres and mood subhubs, so we can do a lot of personalization there as well. Something I've not mentioned here, but like the audio content of podcasts as well is very critical. And increasingly in the last few years, we've kind of doubled down on that. In today's talk, I'm gonna mostly present work from the work we've done with the homepage team, but some of these are around radio, some of these are a bit more search as well, but more often than not, it would be from the home setting. So let me just quickly give you what 10-year, 15-year summary of Rex's approaches in like 100 seconds, and that will just set us up with the background we need to kind of look further. So again, like going back to the Netflix challenge, we know that people started looking into collaborative filtering and matrix factorization, and then doing nearest neighbor search on the user and item space to find content to recommend. And then we thought that, oh, we could expand these matrices to tensors and do tensor factorization, and then learn more contextual representations of users using tensor decomposition approaches. And there's a nice AAA paper back in 2010, which uses this for recommendations. Then a lot of the work in the last 15, 20 years has gone into latent variable models. And a lot of the PhD students have graduated because of the seminal paper, which people wrote in 2003 on latent Dirichlet allocation. So the Rexis community adopted it with full hearts, and they developed a lot of these, like encoded a lot of their recommendation designs into latent variable models and kind of did recommendations on top of that. At the same time, in earlier this decade, a lot of the work on neural embeddings came up, and we started applying them for user embeddings. We started combining them with side embedding, side information, and then like maybe embedding the user and item together. So we did work on matrix factorization, we did work on neural embeddings, and then maybe people thought that we could combine the two. So there was a nice paper in 2017 on neural collaborative ranking. So can we combine the benefit of the neural embeddings with the collaborative filtering approaches? And not just models, right? I mean, like people have looked at variants of the recommendation problem itself. So you can look at some short-term, long-term profile of users. You can look at cold start problems like cohort-based, that maybe I'm a new user, but there may be like 100 million users like me somewhere in the world. So can we do some groupings, latent groupings, and then extrapolate from there? A lot of work has gone into multi-view models and multi-interest models. So my Google Home is used by me, my wife, and my family. So a lot of people use these devices. So perhaps we want to develop a multi-interest model from there. A lot of work recently has also gone into multitask recommendations. So if you look at Rex's paper in last year from the YouTube team, they have in production a multitask model, which kind of recommends you what video to watch next. So again, like as I mentioned, 100 seconds for 20 years. So yeah, the slides will be shared as well. So again, like if you look at a bunch of these approaches, and I'm pretty sure I haven't covered a lot of these, but we start to ask the question, like what is it that they all have in common, right? So what they have in common is the user-centric aspect of these. So we spend decades and decades of work in identifying the user needs, developing personalization models, developing user-centric metrics, and doing all in for user experience. And there's a lot of nice tutorials. I linked one from my manager at Spotify, Munia, on engagement and user engagement at Wisdom 2 years ago. So again, like that's the traditional user-centric focus which we have had when we have been developing in the industry these search and recommendation problems. But the question we ask is that, is caring about the user enough? So you know that a lot of these like billion-dollar unicorn companies coming up are necessarily multi-stakeholder problems. So here, if you pick up Etsy or if you pick up Uber, you have to care not only about the users, but also about the drivers. Or on Airbnb, you have to care about the host and the guest. So essentially, these are all multi-stakeholder problems. And again, I'll be preaching to the choir if I try to convince you guys that these are like multi-sided platforms, which should not just be looking at a myopic view of users and should kind of broaden their algorithmic thinking to encode other stakeholders as well. So with that, that's the main slide, which I'm gonna come back to again and again, that in general, we have multiple stakeholders. So we have the users, we have the drivers on Uber, we have the artists on Spotify, we have the host on Airbnb. The third side could be your delivery partners, the labels in the music industry, the people who deliver Postmates to your home, and also the platform itself. So the platform economics play a huge role in kind of ensuring long-term sustainability of the offering. So the question we ask is that while we have spent decades doing research on user-centric recommendations, how do we kind of walk towards these multi-stakeholder platforms and do recommendations there? So that's what we're going to cover in today's talk. And so what we're going to do is I'm going to spend about 10 minutes in specifying a foundational architecture. So this is a contextual bandit model, which we developed and deployed close to 100% traffic at Spotify homepage about 2 years ago. I'm going to use that to then motivate the need for multi-stakeholder models. And I'm going to formulate a multi-objective bandit model and then kind of present some initial results in that. And later on towards the end, I'm going to spend like some 10 minutes on trying to identify like how can you develop supporting satellite modules which can help your main orchestrator module to do a better job to serve all the stakeholders on the platform. So that's the strategy. We're going to look at a user-centric model first, and then we're going to mature our discussion into multi-stakeholder problems. Cool. So yeah, so user-centric bandits. I'm going to spend like close to 10 minutes. Again, The details are often in the paper. I'm just going to deep dive into only the aspects which are needed for the storytelling later on. So the details of this are explicitly in this paper, which we had at Rex's, which is Explore, Exploit, Explain, Personalizing Recommendations with Bandits. So in general, the question we ask is that how do we explore, exploit over explainable content? So the image you see over here is the typical Spotify homepage. So you have a shelf name, which is over here, like your heavy rotation, and you have a card. So a playlist is what we internally call a card. And a bunch of playlists horizontally in a rectangular, which is horizontal, could be called a shelf. So now if you look at the homepage, then the homepage construction for us is how do we create this grid, right? So you have shelves, and each shelf you have different playlists, and then you have an ordering of shelves. So that's how you can kind of algorithmically look at what your homepage looks like to you. So the question is like, how do we do this? How do we create this? Now, if you zoom in a bit, like I mentioned that we want to do this explore, exploit. And this is, again, like a lot of work in the industry has gone in. I mean, obviously, a lot of work in the academy has gone into developing these. And a lot of industrial systems have adopted and deployed some of these models, right? So in general, a typical bandit style approach would be that is what we follow in a playlist recommendation model. So the goal is, can I learn a policy? So a policy which tells me which card to pick. So card is a playlist. So the user comes onto the homepage. I want to decide which playlist I want to show to the user. Now to create this model, I have a set of candidate actions. So these are some playlists which we have kind of pre-filtered and pre-decided for you, and then we pick from these candidate set. Now the candidate set for us is not like 100 million playlists, right? So we're doing a lot of pre-processing and like pre-candidate generation. So we create a few thousand cards which create the candidate set for you. We have a reward function. We have an exploration strategy on how much you want to explore, how much you want to exploit. So that's a typical bandit setting, which is fairly common these days. But the question is, like, how do we do this on explanations? Now, what exactly are explanations? So if you look at the homepage, then if you see on the right, you have shows you might like or getting cozy for autumn. So these are all explanations which serve as a hook to get users interested into exploring some of these playlists on the homepage. Now, this could be playlist, it could be podcast, or each card could be a mix of either a playlist or a podcast or some specific artist promotions as well. So in general, the explanation, some of these examples are because it's Friday, inspired by your recent history, or because it's a new release, or and so on. So one of the things we have found in our experiments is that finding the right explanation for the right content is key. So just because you're giving the right explanation, that kind of piques the user's interest, and they're willing to kind of explore that a bit more than they would have otherwise. So now the question becomes that should I go back and look at each explanation, look at each item, and then do this like combinatorial search for each user? That's very naive, right? And that kind of makes the problem intractable. So if we do it in a naive way, then the bandit has to try each possible combination of the item, of the explanation, and it has to do it a number of times in order to get some certainty around it, around this combination, and then only it can go and exploit these things. So again, this is non-trivial, right? I mean, we don't want to do this. So this is where we kind of introduce this problem, introduce this model in that paper. So we say that we're going to call our recommendation model set BART. So the homepage team is a huge Simpsons fan. So we even named the current homepage model as BART as well. It's called Bandit for Recommendations as Treatment. And it's composed of 3 key parts. So the first part is a user preference model. So it could be a factorization machine, or it could be your favorite high capacity neural network. And the goal of this part is to kind of look at a user, look at a content, and try to make predictions that the user will stream it, the user will like it, the user might heart it, the user would become a fan of this artist. So it could be any of these objectives. It is conditioned on context. So context could be anything we know about the user, about the item, about region, age group, listening patterns, time of day, and so on. We train some of these models using counterfactual maximum likelihood. So again, this topic in itself is worth like a 2-hour discussion. Unfortunately, I can't go into much details, but we do regularly collect these randomized data collection flights. We train our models using randomized data. And then like we do a lot of like propensity scorings and like counterfactual training, counterfactual evaluation. It took us a while to get it right. We still may not have it exactly right, but then like it was worth the investment we put in about 2-3 years ago on this topic. And then like we have this ranking procedure. So how do we specify the stochastic policy on the explanation grid? So the explanation grid is the homepage which I was talking about. So let me just zoom in and walk through what the ranking procedure looks like. So again, we made the assumption of browsing models. So if you like a horizontal browsing and a vertical scrolling. So if you look at the user awareness, that's your real state on the homepage, then like we can start to create shelves at a time. So essentially what we do is like we apply the bandit model on for each shelf. So essentially you have a set of candidate cards, these cards are your playlist, and then we start to say that, okay, I'm going to sample one playlist at a time and then start creating this. Now I can do it in a horizontal fashion and then create one shelf. So again, this is you applying bandit on a specific shelf, picking up one card at a time, and then arranging these horizontally to get one shelf. So now we can do this and create multiple shelves. Each shelf is corresponding to one explanation which we have. Now what you can do is you can apply another bandit on these shelves. So now instead of doing it horizontally, you can do it vertically. So you have these shelves, and then you pick up one shelf from your policy, and then like you kind of create it. And then essentially you can do it in a vertical fashion, and then that will give you a set of shelves to show to the user. Now this would create your homepage. There's a question on, is this conditional on previously chosen cards or independent? In this work, we have considered it independent. The current production system has some interaction embedded into these things, but the work I'm describing is like assuming independence as such. Amazing thing, right? I mean, like we want to do whole page optimization, and that would be a great problem to work on. But unfortunately, this exactly is not doing a whole page optimization altogether. So I talked about bandits, and one of the things which we want to do is define a reward function. Now, the easiest thing to do is define a reward based on whether or not the user interacts. So if you interact for some certain period of time, then it's great. I'm going to give you a +1. If not, I'm going to give you a 0. So that's the typical easiest reward function we could come up with. A key characteristic of this reward function is that it's global. So all users and all content have the same reward, right? Any user interacting with any type of content, they get the same definition of reward. Now, this is very like kind of stupid, and we don't want to do this. So something very intuitive we tried was we looked at the variations across playlist. So we know that sleep music, I mean, the sole purpose of the sleep music is to make the user fall asleep, right? Or help him or her kind of finding sleep. So again, like we know that the sleep music will be consumed longer than average. And there is like distribution and variation across users. So we know that jazz listeners consume jazz music and other playlists for longer than average as well. So now we are seeing that a global reward function, which says that any user, any item should have the same reward, that's maybe like really very naive, and we don't want to do that. And this is where we want to do a distribution-based reward. So essentially, we had a paper at www last year looking at how do we devise these reward functions on users and condition on users and condition on content. So the key idea there was like, can we kind of co-cluster users and playlists together? So again, nothing fancy here, but the idea is that you look at a bunch of users, you look at a bunch of playlists, do co-clustering, and then for each user group, playlist group, you look at the distribution. And that distribution of consumption allows you to define a reward function. So we tried a few of these approaches. Some worked great, some didn't. But then some of these were like way, way better than the single global reward. Now, there's a lot of caveats into putting this into production, right? Because do you update these clusters over time? Co-clustering at like a 300 million user space is hard and challenging. So a lot of these problems are like non-trivial at scale. But essentially, the bandit model, the BART model I was talking about, so we kind of tested it against a bunch of different models. This is like in 2017, 2018. And we got some amazing wins in online A/B test, and we deployed it at scale. So as of 2 years ago, when you were using Spotify, then you would have gotten your recommendations from a bandit model, which was deployed to like close to 99% traffic. We usually keep a long-term holdback to do a lot of these long-term metric estimations and long-term outcome decisions. So if you're in that holdback group, then you wouldn't have gotten it. Otherwise, like this was powering the homepage. So that's the first part. So again, this is a quick intro in general, and this sets us up with a base for doing multi-objective modeling. So again, the take-home message is that naive combination of explanation and item is combinatorially hard. So these horizontal and vertical shelves make it tractable for us. And in general, very important, but I've not covered, is the off-policy counterfactual evaluation, the counterfactual training, the benefits of explanations we have seen. And often I get asked, like, do these explanations get generated automatically? No, we don't generate explanations automatically. We do a lot of like user research into identifying the user intent on the homepage and then generate these explanations. And a lot of like characteristics about deployment at scale, which I haven't mentioned. But yeah, that sets us up for what we're going to talk about next. So we have looked at a single objective bandit model, and now let's kind of dive deeper into a multi-stakeholder model. Right. So again, we've seen this slide before, that caring about the user perhaps may not be enough. So we want to care about this multi-stakeholders. Now, again, if I only care about user, then I can just have a user-centric objective. This is just an hand wavy example. So I can just have a single objective model and use it and optimize it. But in general, like as we kind of consider more stakeholders, we want to go to multi-objective models. Let's take a small step, right? So when I say multi-stakeholder, multi-objective models, let's just go from 1 to 2. So let's take baby steps and then kind of expand on that and build more. So in the first few slides, we're going to talk about this paper we had at SICM in 2018, which was towards a fair marketplace. That how do we trade off user relevance with exposure of suppliers, so the artist, and then what's the impact on user satisfaction? So I know fairness could be a very heavy, loaded term. And in this paper, by no means we were attempting to quantify fairness or describe what fairness should be on these platforms. We just had a view that you could create any of these, define and quantify fairness however you want. But then like one way to do that could be exposure of suppliers. So essentially what we did was we tried to look at two objectives. One is that I want to show content which is relevant to users. And at the same time, I want to show content which is enough diverse in terms of which artist gets exposed. So I don't want to really focus on the Lady Gagas and Ed Sheerans of the world and just expose them. I want to focus more on the long tail or be more representative in deciding which artists we surface on the platform. Now, again, you can define exactly diversity in like hundreds of different ways. Again, it's not about how you define it. That's another research problem. But just like if we make some initial definitions, then what happens really? So how do you balance these two goals? Now, if you look at this plot, on the x-axis, we have fairness. So fairness is the artist diversity. So things on the right are more diverse. So that's great. Things on the left are not diverse. So that's not good. On the y-axis, we have relevance. So things at the top are highly relevant to the users. Users might love it. Things bottom down are not that relevant. Now, interestingly, right, there's nothing at the top right. So I don't have any good fair content which is relevant to users. Had it been there, my job is done. Then I can just kind of keep on showing that content and everybody's happy. So I do good on artist diversity, I would do good on relevance, and it's a happy world. But that's not the case. And we're seeing that there's a trade-off. I can do one for the other. So yeah, that's a good point. Like, why does the gap exist? So the gap exists because playlists are structured in certain ways, right? I mean, again, like if you quantify your fairness or diversity in other means or on other things, right now this is quantified on playlist. Now, often these playlists are either created by the platform or created by users. So based on what type of playlist you kind of do this analysis on, some of these results might change. But then there is a grouping together. Like I'm going to create a dance music playlist and I'm not going to like combine devotional music with dance music artists together. So often it's also a characteristic of how these things get grouped into a playlist together. But again, like coming back to the main question, like how do we balance these two objectives, right? So again, not to go into specifics, but in general, like we looked at a bunch of policies. So something you can do as simple as like, I don't care about exposure. I only care about relevance. I'm going to optimize for that. Or on the other extreme, I'm going to optimize for supply exposure. You can do some trade-offs in between. You can have a weighted policy or you can have a probabilistic policy. We tried something really nice on the guaranteed relevance. So oftentimes when we talk to product managers, they're not okay with us tanking relevance. So they want guarantees that can you guarantee me that you're not going to go beyond, let's say, 0.8 relevance, and then I'll allow you to do whatever you want on the other objectives. We also tried some adaptive policies. Adaptive policies are user aware. So some users are okay with diversity, some users are not. We quantified that and we brought them into the optimization objective and did some work on that. Again, a lot of details are in the paper, but interestingly and conveniently, it was great that we saw that there are inflection points which provide good trade-off. So these things marked on the red color in the red circle show that maybe I can get decent enough gains in my diversity without impacting relevance so much and without impacting satisfaction so much. Now, this is great because it's a very promising result and we can double down on it. Now, the thing is actually worth mentioning, like there's a lot of very cool results on user adaptivity over here in this paper, which highlight that quantifying user adaptiveness is key. And it would be nice to leverage, quantify them and make it available to the model. So I'm skimming over some of those details. But interestingly, right, we're starting to see that at least a two objective world is sane and it's an easier, relatively easier world. But as and when we go towards multiple objectives, it becomes harder. So let me quickly give you a quick example here. So let's say I care about three objectives: user satisfaction, supply diversity, and promotions. So on user satisfaction, I care about clicks, I care about stream time, I care about how many items you consume. On diversity and promotion, I have one goal each. So now suddenly we are in this like 5 objective world. And just a quick heat map of the correlation shows that like different SAT metrics, SAT is a short form for satisfaction. So different satisfaction metrics are correlated. So if you optimize for one, you get the other for free. That's great. The supply diversity is almost neutral with SAT metrics. So again, like you don't get it for free. So if you care about diversity, you really have to optimize for diversity. And certain promotional objectives. So promotions could be that we want to promote more female playlists or some Black artist playlists or whatever, like different type of content you can try to promote explicitly in your recommendations. So again, like they may not go very well with the user goals, right? So you start to see that negative correlation pop up. So this is why like just weighted averaging is not enough. I mean, the objectives functions I was showing you, they are not like rich enough to express these multi-objective traits. So this is where we had a paper at KDD earlier this year, which is trying to do this problem in a multi-objective setting. So can we develop multi-objective models, multi-objective bandit models to do this at scale? So essentially, I've shown this slide enough number of times. The goal is that instead of a single objective bandit, I want to do a multi-objective bandit. And there's a lot of work around Gini functions. So there's an ICML paper in 2018, which looks at like a bandit-based formulation, not a contextual bandit, but a bandit-based formulation of Gini functions. So then we borrowed some ideas from there and said that, okay, we want to be able to do this in a contextual bandit setting. So remember, the model which I talked about before 10 minutes ago was a contextual bandit because we heavily rely on context. So again, like, can we make our contextual bandit models multi-objective? So what we did is we said that we're going to look at this generalized Gini function, which is a special form of OWA. OWA is like ordered weighted averaging. It kind of preserves impartiality with respect to the individual criteria. So again, like if you optimize this function and each of your constituents here are the different objectives you care about, then it kind of prefers allocations which are a bit more equitable across your different objectives. So what does it look like? So in general, the goal for us, as is in any typical bandit setting, is to find an arm selection strategy. So in a bandit terminology, arms are like the arms in your slot machines and casinos. So selecting an arm means I'm going to select a card. That means I'm going to select a playlist and show to the user. So ideally, I want to learn this arm selection strategy, this playlist selection strategy, which I can use to decide which playlist to show. Now, for each bandit instance at round T, we have a set of features. Now, these are the context features I was talking about. Anything and everything you know about the user, including the most real-time available features you can put in over here, and that's the context you have. Now, in general, if I choose an arm K, right? If I pick up a playlist, in general, I would have observed a reward. Now, in a multi-objective world, we don't have a single reward. We have a vector of rewards because I have 5 objectives. So each decision, each arm selection will give me 5 rewards in general. So now, if the mean feedback for each playlist was known, then again, it's a easier problem. I can do a full parameter sweep, pick up the max, and then show to the user. But because a lot of times your rewards are conditioned on context, so we cannot do that. So instead, what we do is we maximize this function G over here. And this function G is the exact function I was talking about. So that's the Gini, generalized Gini formulation of your objectives. So essentially, like what you get is like if you optimize this multi-objective model, then you start to see that you're creating gains across multiple objectives. Okay, so just like a hand-wavy example of what exactly it's doing deep inside. So again, like we have some parameters, the number of objectives, number of arms. We start with a uniform strategy that each card has an equal likelihood to be picked up, and we initialize some auxiliary matrices. In general, at each round, we observe a set of context, right? So each round is a user coming to the homepage and we deciding to create that homepage using this bandit model. So we observe these key features, which is the context, and then we make an estimate of rewards. So again, this is us using some trained ridge regression models to kind of predict what the rewards could be. And in general, based on that prediction, we have to pick up an arm and show it to the user. So oftentimes, like we have to project it back onto the action space and then use that to kind of pick up an arm, show to the user reacts, we observe the other rewards, and then we can kind of go back and update our models. So that's the background on what exactly is going on here. Now, we got some really promising results when we kind of tried this internally. So in general, let's just look at a multi-objective setting, right? But here, I don't care about any other stakeholder. I only care about user satisfactions. So if I only care about satisfactions, not marketplace at all, then I care about clicks, stream time, some total number of songs played, and so on. So the yellow thing on the right is the multi-objective model, which we were just talking about. So we saw that the multi-objective model performs much better than each of these single objectives on each of these objectives themselves. Now, this is very interesting because if you optimize for clicks, then you won't get as high a gain as when you optimize for all of these together. So this is a very nice takeaway that optimizing for multiple interaction metrics performs better for each metric than directly optimizing that metric itself. Now, this is very, it was very illuminating for us because there is some work in the literature saying that often these metrics have these inherent chaining structure. Like you have to have a click in order to have a 30-second stream. You have to have many 30-second streams in order to have a deep, dense session. You have to have a very dense session in order for you to have like a 2-hour-long session. So perhaps there is inherent chaining effects which are prevalent in these metrics so that now your models are able to kind of learn from these latent structures in a multi-objective way, which you wouldn't have otherwise covered, essentially. So in general, like we've seen evidence that this is important because not all teams care about multiple stakeholders and not all industries care about that. But the claim over here is that even if you don't care about other stakeholders, just about users, then also we should be looking at a multi-objective user-centric model itself, and that might be beneficial. Now, this is something off the hook. We recently deployed on the radio platform. So again, like this is across 300 million users. So if you're using radio as of today, we recently, like just last month, shipped a multi-objective model for user satisfaction on your radio. It's not a bandit model, which I'm talking about here. That work is under review right now. But right now, the radio system on your Spotify is powered by a multi-objective user interaction prediction model. Let's start adding a competing objective. So let's say I say that I want to expose some gender. So I pick up a set of artists and create this like hypothetical group of promoted content. And we are starting to see that here we can get decent gains in the promotional objective without hurting user-centric metrics. Now this was again a very good win for us because we found from our offline evaluation that it need not be a zero-sum game. That if I have to benefit my artist, I need not hurt my users. Now, 10 minutes ago, I was talking about trade-off, and trade-off is necessarily a negative annotation word, right? You win some, lose some. Here, we are starting to see that perhaps we can get gains in business objectives without loss in user-centric objectives. Now, this is by no means a generalized claim we are making here. This is like specifically in our case of music recommendations, we saw that there are often scope of improving on satisfaction without actually improving on business objectives like promotions and artist discoveries without hurting users. An obvious statement to mention here is like, of course, it depends on how complex and how sophisticated your user satisfaction model is. If it's like really naive, it's easier to gain on that. Of course, all these kind of caveats apply. But again, it was a very good result, which motivated a lot of internal projects around doing it in a coordinated fashion, benefiting users, benefiting artists, and so on. And finally, we tried out some variants of multi-objective models, and it's not a given, like nothing fancy here, just that how you do it matters a lot, not just any multi-objective model will give you the gains which we are seeing. So that's the end of the second part, and I think we're doing good on time. The the goal, okay, the takeaway message so far is that there's often an interplay between objectives. And in general, the multi-objective bundles are kind of useful. But the one takeaway, if you want to have up until now, is that it need not be a zero-sum game. And perhaps we can make some gains on some artist metrics without hurting users at all. Again, not covered are two-stage ranking and the objective balancing techniques. So objective balancing is something which we have recently deployed on radio, and it has given us very, very significant metric wins on user happiness. So in general, yeah, let me take a step back and say where we are. So we've looked at a single object model. We've now looked at what a multi-objective model might look like. Now let me just kind of show you a glimpse of like many different projects with the goal of helping your main global orchestrator. So let me show what I mean by that. So in general, the way we have been thinking about these problems is that you have your main matching model, right? I mean, it could be a market design problem for you later on. For us, it's a multi-objective recommendation problem. Now, what we want to do is we want to enrich this core system by many independent learnable modules so that my main algorithmic balancer does have intelligent input coming in. So here, in this part, I'm going to give you a few examples of projects which we have done. Again, I'm not going to go into a lot of details in each, but just to give you a sense of the kind of problems we attack to benefit the main decisioning, the main multi-objective decisioning. So let's just look at a couple of examples on user understanding. So I know this paper recently got famous a bit more again on Twitter. So I'm happy to kind of discuss this in detail in the discussion part as well. But we have this paper. Ashton is, so he's a contractor with us at Spotify. He's affiliated officially with University of Toronto. So we did some work with him, and this is work on consumption diversity. So we want to understand, like, do users consume diverse content or not? And how does that interplay between your organic consumption and the program consumption, which Spotify models do for you? So we found some great analysis and we found some great results that certain users are specialists. So they have a very narrow focus of what they want to listen. Certain other users are generalist. And in generalist, like, you have a much broader horizon of your streaming activity. And in general, very interestingly, we found that the generalists and specialists exhibit different retention and conversion behavior. So again, like, if you are a generalist, you would expect diversity in your recommendations. And if we don't give you that diversity through our programming, then you may not retain on that product. And also, like, you may not convert. So convert from a free user to a paid customer. So again, this is important and interesting. Remember, 20 minutes ago, I was talking about adaptive models, that some users want diversity and we can be adaptive. So if users want it, then it's great. I mean, then it's like a Lego match. But some users don't want it, then perhaps you shouldn't be doing it. So I think, like, it's very obvious retrospectively, but it kind of makes sense to quantify these scores on a user level basis and then support your kind of decision, algorithmic decisions to kind of follow that. Now, very importantly, right? I mean, it's not as easy as this slide is making it sound. Why? Because there's a lot of confounding going on here. Because, I mean, if we want to disentangle the organic streaming from program streaming, then there's a lot of intermingling going on. Like, your organic streaming is coming in from your playlist. The playlists you create. The playlists you create are based on the discoveries you do. The discoveries you do on radio are based on the programming we do for you. So often, like, again, nothing specific only to Spotify use case, but because of the entanglement between our programming and your organic consumption, it's hard to disentangle the organic behavior of users versus the program behavior, their behavior on program content. So again, a lot of very interesting problems in this domain. Another thing which we did was to quantify user receptivity. So we had a paper at Rexis earlier this year with the goal of quantifying and predicting user receptivity. So in general, the goal of this project was to say that let's pick up diversity, right? Or discovery. So users like familiar music, but they also want to discover more content. Now, the user's appetite for discovery is not fixed. So some users want more, some users want less. So in general, and also, like, distortion. So, I mean, I've been talking about randomizing recommendations on the homepage to create these counterfactual evaluation models. Now, not all users are okay with that randomization, and certain users are more okay than not, right? So in general, any of this concept, like, if you want to do more diversity, if you want to do more discovery, if you want to do more randomization, like some users are receptive and some users are not. So we should be kind of making these prediction models which quantify user receptivity. And if I have these models, then I can use them in my multi-objective decisioning to kind of make better decisions. So this is like another one of those examples wherein we found that we can predict user receptivity to a good extent and then use them in our decisioning. So that's the couple of examples on understanding user insights. And again, we have a few more. We did some work on user intent. So some user intents are very narrow and they're very specific. So if the user intent is specific, then not much you can do. But if the user intent is broad, then maybe there is that other struggling artist, which we can surface here right now, because the user intent is like pretty broad and they might be okay with some general recommendations as well. So let me give you a couple of examples on the content side. So how do we leverage content understanding to kind of make better decisions? So this is a work which we did with the search team, and we tried out this test in May, June this year on the search by partnership with the search team. And the goal here was to kind of identify the queries, right? So when you're searching, then we kind of create this notion of non-focused queries. So often users are open to non-specific recommendations. So if you're looking for Coldplay Paradise, then that's a very specific recommendation. Whereas if you search for relaxing music, then like we have a lot more ability to influence and go beyond what you might typically listen. So again, like this is an opportunity for us to surface underserved content. Now this is a very heavy term, right? What do we mean by underserved content? Now, as a platform, you can do your work, you can do your homework, and then kind of identify what is an underserved content. So again, like we're just skimming through this here, but even identifying underserved content is a very important research question for us to kind of get right. And then like once you have this underserved content, then you want to hunt for opportunities wherein you can show this content to users. And it's a trade-off problem, right? Because if you overdo it, users will not like it and your satisfaction metric tanks. And at the same time, like you want to balance satisfaction with the exposure gain for your underserved content. So again, the plot over here are some normalized metrics from our A/B test from May, June this year around how do we balance like surfacing more underserved content and like how users are okay with some of these and some not. So again, like identifying queries gives you this opportunity space mapping that often there are these queries and I can perhaps shift my consumption and kind of expose some of these underserved content, underserved artists in and make their kind of careers better. And finally, just a last project, which we're going to talk about more in the upcoming paper at Wisdom next year, which is how do we optimize for diversity in our recommendation models? So now diversity is an age-old topic. A lot of work has gone into it. But in general, what we see is that diversity is good. I mean, users love diversity, right? If they like it. But diversity is not just about users. Diversity is also an enabler for consumption shifting. So you want to shift consumption towards underserved artists, underserved suppliers on your platform. So now diversity is a way which some users want diversity, and if you can combine the users' need for diversity and the need for surfacing some of your suppliers on the platform, then you can view as diversity as an enabler for shifting consumption. And what we did was we developed some models. Specifically, we looked at a reinforcement learning model, which we've offline tried, and we kind of almost there in terms of like testing some of these things internally via A/B test. But the goal of this project was that can we develop these long-term reinforcement learning models which have a reward function which not only cares about users but also diversity. And in this plot over here, like we're starting to see that the blue thing is when you're optimizing for diversity as well, and you're starting to slowly shift consumption from one side to make it a bit more spread out across different suppliers as well. So that's the third part. So in general, like the take-home messages is that while we develop the main models, like we can enrich by developing better user understanding, and user understanding helps us in like pushing other objectives without hurting key user metrics. So we looked at user receptivity, we looked at consumption diversity. Some other work which we have done is like intent identification and how do we do that at scale and use them in our decisioning. In terms of content understanding, we can look at personalized reward functions, query understanding, like you can look at diversity. We also did some work on artist understanding, like so again, if you intervene on one artist, it's going to have ripple effect on the other artists as well. So we've touched upon a couple of projects on that topic as well internally. So that's the end of today's talk. Just to summarize, I guess the picture I want to paint is perhaps nothing new in the platform ecosystem world, but in the recommendations community, as we evolve our thinking from a user-centric system to a multi-stakeholder system, then ideally what we are doing is we are looking at detailed deep dives on users, developing models for them, developing models for artist and supply understanding, developing models for platform objectives, long-term value, and then kind of using these satellite modules to provide intelligence to your algorithmic balancing system, which could be auction mechanism in future. Currently, it's a multi-objective model which we use. It incorporates feedback, adaptive decisioning, a lot of details on measurement and evaluation, and like doing counterfactual evaluations, doing long-term evaluations, and all that. And in general, that's a picture I want to paint at the end. Finally, essentially, this was a 45-minute dense talk condensing a tutorial which we gave at KDD, wherein we also talked about how other companies have kind of looked at some of these problems, some nice blog posts and articles from LinkedIn and Uber Eats on this topic. And in general, if you're interested, we have a bunch of very interesting data sets publicly. So the Rex's challenge has about 1 million user-created playlists. Last year, as part of Wisdom, I was involved in kind of making public 1 million user sessions. So that's a very rich data, because when I was doing my PhD, then we didn't have a lot of user interaction data on an item level available in a session. So that's a data set. This year, we released a Trek podcast track data set, which had 100,000 podcast episodes for us to do a lot of like a natural language understanding and content understanding on that as well. So I think like the bigger picture over here is that Spotify, like we really want to have more academic collaborations. We really want to do good work in the academic community as well by enabling other researchers to kind of use our data and kind of solve important problems. With that, I'll end, and hopefully we'll have at least 13 minutes for discussions.
Awesome. Thanks, Rishab. That was fast and furious. Very much appreciate it. One quick question to get out of the way. I think a lot of people have asked if they can have access to your slides. Are you cool with that?
Yes, for sure. Yeah. I'll post my slides.
All right, good. So I think for Q&A, I think what I'd like to do is invite a couple of people to come off of mute and show your video if you prefer to put forward some questions. There are a bunch in the chat section, and I think Suchizmit Mahapatra has maybe put forward the most questions. So Suchizmit, are you available to come off of mute and ask your questions?
Yeah, sure.
Perfect.
So can I ask now?
Yeah, go for it, please.
Yeah, sure. Yeah, so so could you share the URL for the ICML 2018 paper that you talked about?
Yep. I'll share it somehow. I don't want to find it right now. It's there in the KDD paper which I talked about. So there's a reference to that, but I'll also kind of find the link and share it in the chat.
Yeah, and also you said that there are two aspects, that is user satisfaction and relevance. Isn't there a monetary aspect as well? Which tracks provide more revenue?
Right. Yeah. So I think like in there, right, the point I was trying to make was that even if you just start small, like of course you can have like monetary aspects and like long-term sustainability of the user of the platform aspect. But there, I guess what I was trying to convey was that a baby step direction is like just going from user relevance to user relevance and supplier exposure. So you can add in a lot more revenue goals, a lot more originals goals. Like Netflix has a lot of like Netflix originals content, right, which they want to surface. Amazon has Amazon Basics. A lot of their products are there. So again, like there's a lot of goals which we might want to loop in on the platform economic side of things. But for sure, yes. I mean, the short answer is yes, we can do that. What I was alluding to was that can we just start small and start looking at supplier exposure diversity and what happens when we just optimize for 2, and how can we use that learnings from there to kind of optimize for like more than 2, right? So that's the story which I was alluding to.
Yeah, I have a couple more questions. So first question is, You talked about this threshold value, which you wait for, and you assign a reward of 1 with if it's within some threshold. So I think that is a big problem in ad tech also. How long do you wait for a click? How long do you wait for an action? How do you kind of associate an action with a particular impression? So just in your case, how did you decide on this? Or have you done any work on this? Yeah.
Yeah, so I think like I think that the slides right following that was like, can we look at distribution of the rewards? So maybe in ads, like there are certain types of ad wherein the users would immediately click or never click at all. Or maybe there are certain segments of content wherein like it's expected that users will kind of click after 5-minute delay. So we found that in our case that there are variations across users, there are variations across playlist. And if you look at user and playlist co-clusters, and then for that specific group of users and playlist, look at the distribution and then design your reward functions. So I think like that's what gave us some good wins. So
Yeah, that
I mean,
makes
not
sense.
being globally prescriptive about it, but let your actual like user playlist level data decide that.
Yeah, and you also mentioned that working on just a multi-objective works very well, and that each individual objective seems to be satisfied. But I think it depends a lot on how you design your objectives, what is the metric you are using. So that is a very difficult problem to understand what metric to use.
I agree. I couldn't agree more, right? I mean, like, there's a lot of caveats which go into that claim, and I don't want to be making a bold claim on that note. I think like a lot of it has to depend on, again, like, look, if your objectives are all correlated with like positive correlation, then by definition it's going to happen, right? So the more you add in non-competing objectives, the easier it becomes for you. The more you add in competition in there, the harder it becomes for you. But one thing which we have realized is that music in general, like if you go to web search, if I go to search on Google for something, I have a very specific need. But oftentimes in music, perhaps the domain allows you some elasticity on user needs. So if you're able to identify in real time that this user session could be a bit more elastic than usual, then I mean you have a lot of like leeway to play with, right? So I think that's what I'm getting to, that the music domain itself need not be very prescriptive. The user is not really always sure what they want, and they're broad enough. And in that broad enough world, you get more power in order to kind of surface some other artists which the user may love to discover. So this is where like looking at discovery, looking at connections, the users form a connection with artists. So if there's a high chance you might love this artist, so I might want to make you discover this artist, and then you go on to create a connection with that artist. So oftentimes you kind of shape users' listening habits on the fly, which is very different from what happens in like search or other, like if I go to Amazon, then I really have some product things which I really want. Maybe there's some elasticity there. But I mean, coming back to your point, I think you're totally right that by definition, it depends on like how easy your objectives go along with each other.
And you also had this point that is very difficult to understand which items or which songs are not used that often or listened to that often. But can't you look at some sort of completion or listenability rate or frequencies to
Sure,
understand?
right. Yeah. So I think my point was like underserved content, right? That is conditioned on what we think its exposure and consumption should be, right? So there you're supposed to play God. That I mean, we can't play God and say, hey, I mean, this track should have had 10,000 streams, it only had 2,000 streams. So it's hard for you to do the counterfactual. That in an ideal world, what should the number of streams be? And you from the current stream rate you have, you subtract and then say, okay, this is underserved or not. So I think like what you don't have is like, what's the target? Like, should it have like 10,000 streams or like 100,000 streams? You don't know, because that's a counterfactual question, which is hard for us to answer. So identifying underserved content is hard. I mean, you can look at like global estimates and global averages, and then you can define an underserved content, but that's one way to look at it. Like doing it in the right way, that's the harder thing.
Yeah, and thanks for the great talk. It was very nice. Thank you. Yeah.
Thanks, Suchizbit. Michael Schrag, I know you have a question.
Yes, I want to echo what you just heard. That was a terrific, terrific talk. And the whole notion of how one manages a portfolio of these things, multi-objective portfolio as opposed to individual, that's fascinating, and that's going to play off. But I have a slightly different question, which is at the intersection of quote unquote music and where you're going forward. You guys are looking at podcasts as well. How do you migrate your multi-objective platform balancing approach so that not only are you going to recommend music for me, you're going to recommend which Joe Rogan podcasts I hear. Is that an easy, continuous, explore, exploit mechanism, or is that really going to internally disrupt the way you've set up your recommendation infrastructure?
So I think like there's an answer I want to hear, which is I hope it isn't as disruptive. Like I would love for us to just kind of continue on this trajectory without making like drastic changes. But I do also acknowledge that we're talking about different abstractions here. So when we talk about podcasts, so we have a paper at Sigaya this year, which was talking about, does podcast consumption cannibalize on music consumption? And again, like if we surface more podcasts, then it really doesn't mean like you're consuming less of music. So I think like the kind of questions we begin to answer there are multi-objective in a different abstraction as well.
That's why I asked the question.
Right. So I would love for you to kind of take a look at the paper which we had at Sigayar, which is like literally showing that you need not decrease your music consumption if you're increasing your podcast consumption. So again, there's no global answer, right? Some users might like it, some users might increase your overall time they spend on the platform, and that's great because then we can distribute the surplus. But I think like philosophically in terms of thinking, the models which we have are amenable to more objectives being added, as long as you're willing to add the supporting ecosystem needs for that.
So my quick interruption on this, and then we can go to another question is, will, as an A/B experiment, because you've already incorporated multi-objective stuff in this, will as an A/B experiment, will you let Spotify subscribers opt in to podcast recommendations in the same way you're looking at generalist versus specialist, somebody who's looking for a broader, your word, diversity of things? Is this the way you would do extension of the recommendation capabilities into your 300 million plus listener base?
Yeah, I see your question has a lot more depth into what I can go into officially. And as a researcher, like I cannot say enough on the product strategy as well. But at the same time, I would want to just mention that we're starting to uncover eliciting more input from users. I know we are doing a lot already, but there's just no upper limit on how much you can elicit from users. I, as a user, would love to tell more. I want you to play a game with me for all I care. And I'll tell you everything I want. So I think like that level is not there yet, right? I mean, as a user, as a consumer, also I have some like demands and needs from the platforms I use. So I think like internally, we are making some strides in 2021 around eliciting more feedback from users, because then at least like we're not second guessing them, and we can always use that as an input to guide our models. So I totally hear you. Yeah.
Excellent. And I wasn't trying to get you into trouble. My apologies.
No, for sure. No, yeah.
Actually, he was, Rishab, but we'll let it ride. Arpita, are you there with a question?
Yes. Hi. Can you hear me?
Yes. Yep. Yeah, we got you.
Okay. Hi. So Rishabh, that was like an excellent talk and absolutely amazing. So I have a very minor point on you you showed the Gini index, and I was curious, like how do you get the weights which you require for the computation?
Yeah. So I have a two-part answer to that. One is like in the paper, like the weights are learned by the function itself, right? So the weights are the parameters which you learn during the training process. And in the training, you do counterfactual training. So oftentimes you have some counterfactual means like you have some randomized data wherein you have had some instances of doing one objective more than the other and corresponding impact on rewards you get and other cases, right? So I think like the weights in general are learned, but also if you go beyond, like Gini function is a specific form of OWA. OWAs are like ordered weighted averages. So you can parameterize those functions and learn those parameters as well. So in general, if you look at some of these, like so there's some line of work around fuzzy aggregations, which look at Choquet integrals, wherein you can define some measures on top of your objective space, and then like let that measure. This is a probabilistic measure. The probabilistic measure decide your weights. So I think like you can go a bit beyond and like learn the hyperparameters of your like weight parameters as well. But the short answer is like in this paper, we learn them as part of the learning process.
Awesome.
Okay. Great. Yeah, I have another quick question. I think there's something I did not understand. So you spoke about user satisfaction, which is it directly proportional to if they have listened to a song or not, or is it something
Yeah,
else?
so we have a lot more nuanced definition of it. Like, so you can look at short-term satisfaction as like you're streaming some content. So you can look at like reach. Reach is like you consuming something on home. You can have a depth session on home. You stay on the homepage for like 30 minutes and stream like 10 plus songs. You can retain on the home. We want you to come back, like 7-day retention, 14-day retention. So I think like in any industry you look at, user satisfaction is a lot more nuanced, and there's a wide array of metrics which teams look at to decide. You can also look at downstream. So I don't want you to just stream an artist for once and forget about him. We want you to stream that artist like 7 days from now as well. So you start to create this connection with that artist. So a lot of the metrics which we have are a lot more like more nuanced into like long-term connection between users and artists as well.
Cool. Thank you, Arpita. Thanks, Rishab. We're at the end of our session today. I want to thank you very much for an awesome talk. Good Q&A. Appreciate it very much. This is the last seminar of the semester. We'll revisit the schedule again at the end of January. I hope that you and yours will have a wonderful holiday season in spite of the issues we have in our environment. So be safe, be healthy, enjoy your family. Happy holidays.